Hey everyone, I'm Mike Knoop, co-founder of Zapier and ARC-AGI. Zapier, if you don't know, it's an automation company. We connect lots of integrations together, allow folks that technical ability to create workflows. And for 10 years, I've run Zapier's product engineering and our AI teams. In the summer of 2022, about 2 years ago now, I gave it all up to go back to being just an AI researcher. And that led me to teaming up with François Chollet, an AI researcher, and we just launched ARC-AGI last month. I'm excited to share a little more about both today. These are some of the product categories that I've been responsible for at Zapier, probably the main ones. Zapier is probably best known for Zaps, our workflow builder. Works with 7,000 integrations now, again, designed for sort of non-technical users to be able to connect apps together and automate workflows. Myself, I kind of think of myself as an engineer though, and I actually use Zapier as well. One of the things I use Zapier for is to prototype software. I find it's easier to do than having to go, host and find an ID and all that good stuff. That was such a popular thing that we saw our users doing that we launched this year, Zapier Tables and Interfaces, which are new products. Tables is a no-code automation-first database product. And Interfaces is a no-code automation first interface builder. You can build dashboards and forms and things like that. Together, you can basically build software, and it's all designed to be incredibly easy to use for non-technical users. One of the newest categories that I've been working on, a lot of time last year is this last one, Zapier bots. So Zapier bots are basically a ground-up reimagining of automation. One of the things I've kind of gained an appreciation for working in AI the last couple of years is that I think the promise of automation and narrow AI is the same thing. Basically, what do people want? They want software that just does work for them. This is what Zapier does. I think this is what people want AI to do for them. Over the last 10 years, we've 2 million business or so, 10 million users over the last 10 years. But we want hundreds of millions of people being able to get leverage from this stuff. And I kind of at this point believe that structured canvas, builders aren't going to get there. We need something new. We need some sort of new paradigm. And I think that's where bots get really interesting because these bots are defined 100% through natural language. No more point and click structured building. Instead, you get a text box. You get to tell the bot what you want it to do. And unlike other sort of AI automation products, these bots are the core of this system is through natural language as well. So not only do you set the bots up through natural language, but you actually steer and guide and aircraft and debug and fix them entirely through natural language. And I think this is what opens up the sort of aperture of the number of people in the world, the number of knowledge workers that can actually use this software. I think Zapier was one of the first. I think Zapier was one of the first sort of large companies to go all in on AI at the application layer. We were launch partners with ChatGPT and the ChatGPT store last year. And I'd love to be corrected if this is not right or anyone knows in the audience something that's opposite of this. I think Zapier may have the world's most fully automated AI usage in the world right now. We do about 10 million automated tasks a month that use AI. These are tasks that have no sort of human in the loop, right? That's not how Zapier works. Zapier works by, triggering off of something automatically and doing something automatically in response to that. And so I think Zapier actually we have a pretty good insight into what are people actually doing with AI in these like automated, or what are they trying to do use AI for in these fully automated deployment scenarios? Over half the company now uses AI on a daily basis as well. Like I mentioned, we're sort of launch partners with all the ChatGPT stuff last year. Pretty much every team and product that's Zapier uses AI. And I think one of the important things I've learned getting to this point is how important evals are in AI. In the old days of deterministic software, you could build software and test it with 5 to 10 users, right? You could sit a couple users down on a laptop and have them try your software. And you knew if it worked for maybe 5 or 10, that the business logic, if it was bug free, it did what the user wanted, it would scale up to 1,000, it would scale up to 10,000, it would scale up to 1 million. And that is not true in this new AI first product building era. The only way to actually know whether your products work at 1,000 users, 10,000 users, 1 million users with AI is you actually have to deploy at that level and measure and assess. That's the only way to actually assess quality. And the reason is because the input diversity into the system is so much wider than it was with the classic sort of deterministic software we've had in the past. One anecdote on this, to kind of highlight the story. We launched a developer product last year called AI Actions, which is a developer service that allows third-party developers to plug Zapier's integration platform into your own into your own applications, their own products you're building. And it uses AI in the loop of like being able to call, send a Slack message, grab an email in my inbox, grab a bunch of HubSpot leads and match a search query. And when we first launched this, we had no idea how good it was. We didn't even have an eval against it. We were just doing vibe checks when we launched this. And it was originally, when we launched, only about maybe like 35 or 40% active. We knew this because when we did launch, we had like feedback measures on it, both explicit and implicit. We had the thumbs up, thumbs down. We had text feedback. We were also looking at like the API error rates, looking at the success rates of the code that was being generated, stack analysis. We're able to see the system was like not good. And yet over the next 2 months, we built another system that like took all that feedback in and guided our product and engineering teams in order to improve it. And over the last summer, we were able to get from 40% all the way up to 85%, which is where, it sort of like hangs around today. So it's really, really important. This concept of like benchmarking and measuring is really important in AI. This is one of the things that ultimately led me to, sort of giving up my exec team role back in 2022. I was just really personally curious, like how far off are we from AGI? I think the thing that really startled me was the chain of thought paper that came out in January 2022. This was I'd sort of like been paying attention to GPT-2 and 3, gave all presentation to Zapier on those. And I thought I had all priced in. And then when I saw that chain of thought paper that was like going from like 30% performance on these reasoning benchmarks to something like 80%, that was a huge leap. And kind of like shocked me out of the sort of role I was in and said, I'm going to go try and figure this out. Are we on path for AGI? This is really important for our customers, for our business, but just like as a human, like curious, like, don't you want to know, like, are we just on path to AGI or not at this point? That felt like really, really important to know. And turns out the answer is no. And I'd like to walk you through what I saw and what I discovered that led me to believe that. So there's first thing I found, there's really no like established agreed definition of what AGI even is. There's basically, I maybe call, there's two big schools of thought in the world today. The first is kind of represented by a lot of these perspective quotes on Twitter, and you can stop on this interview he gave like last month. First one is that like AGI is undefinable. We'll know it when we see it, and we shouldn't even try to define it separately. I think this is the wrong perspective because I think benchmarks in general our definitions are really, really important because as a society, we turn those definitions into benchmarks, into things we can measure. We use those benchmarks and measures to direct and guide energy and progress of our sort of entire ecosystem of like building and tech. This is very important. I don't think we should sort of accept, I know it when I'll see it. The other school of thought is from the OpenAI Microsoft agreement. So this is the definition they have actually written into their like partnership agreement from several years ago. And said AGI is a system that can outperform humans at the majority of economically useful work. I think Chollet gets credit for originally pointing and coming up with this one, but certainly due to the success of OpenAI, this definition has become fairly accepted, I think, in sort of the industry today of a way of knowing how far or how close are we to AGI. And I think this is a fine goal to shoot for. In fact, I'd argue that narrow AI is already within shooting distance of achieving this goal without any artificial general intelligence at all. And so I think this shows that, like, we need something more. I think this definition maybe like out of this fast shows that like I think it says something useful about like automation, but I don't think it says anything at all about what AGI actually is. So I'm going to skip ahead. I'm just going to give you the answer. So AGI is instead a system that can efficiently acquire new skill and apply it. This definition is credit to François Chollet. First got exposed to his work all the way back during COVID. I think it was like a Lex Friedman interview I was listening to. Here's a thought experiment to remember this, by the way, kind of like rocket. So we've had narrow AI systems now for 5+ years that can outperform humans at like games of skill, things like poker, chess, Go, even diplomacy in like the last couple of years, which is pretty cool and special. The fact remains, though, that the way that these systems work is, researchers and engineers have to like tear the system all the way down to zero and start over when they go try to beat another skill game. They're not able to reuse a lot of the work they did in the past. They have to, invent new search algorithms. They have to go acquire new training data. They have to reach new levels of, scale in order to beat humans at these games. Yet I could take every single person here in the room and I could sit you down and I could like teach you a new card game, get you up to human level proficiency probably in a couple hours. I could then immediately switch gears and teach you a new board game, probably get you up to human level proficiency in just a few hours. And I think this shows that skill alone is not general intelligence. Instead, general intelligence is your ability to very rapidly and efficiently acquire that new skill across domain. And that's what no AI system today can do. That's what we don't have. That's what no one knows how to build in the world right now. In fact, last year, Bill Brown, who's one of the researchers most famous, I think, for several of these systems that can be humans at games. Things like, I think he got most famous for poker 10 years ago, worked at Meta doing the diplomacy bot, Cicero. Last year, he did a podcast and he said, I think that games of skill are a solved problem. They're no longer interesting to work on. And now what they're doing, he's working at OpenAI as the head of reasoning. I'll note, working on new ideas. So working on all this eval stuff is kind of what led me recently to rediscover Chollet's work. I'd seen all these like AI benchmarks that we have, MLU, GSK5AK. All these were like saturating up to human level performance, and they were like more rapidly getting there than prior years. And when I started looking back into Chollet's work, in his definition, François introduced this thing called ARC. It's called the abstraction reasoning corpus. And I had sort of expected to see this benchmark also reaching in saturating human level performance. And in fact, I'd seen the opposite. It was actually decelerating, at least up until a month ago. It's actually decelerating. The more I dug into understand like why is it decelerating, I realized this isn't just like an accident that it's decelerating. There's actually like a conceptual grounding and framework for why. So these are some sample ARC task puzzles. If you haven't seen them, you can go to arcprize.org and actually play with these and take them on the website if you want to try them yourself. The idea is that ARC tasks are very straightforward and simple for humans, and yet they're impossible as a set for AI to solve today. We know 100% of these tasks are human solvable. Every single one has been hand verified by humans. We know they all are human solvable. Solving these tasks requires no world knowledge. So you don't need encyclopedia. You don't need language necessarily in order to solve these tasks. Instead, they test your ability to compose core knowledge priors, things like goal directedness, objectness, symmetry, rotation, reflection. These are core knowledge skills that you acquired really early on in your childhood development. As early as 1, 2, 3, 4, 5 years old, you're acquiring these skills. And ARC tests your ability to compose and build patterns and identify patterns that solve these puzzles that you've never seen before. Chollet designed ARC to be highly resistant to memorization. This benchmark was designed in 2019, before LLMs even existed. It was designed to resist memorization. That's the thing that LLMs are superhuman at today. I think the fact that ARC remains unbeaten, by the way, is not for lack of effort. 300 teams tried to beat ARC last year. Most of the big AI labs that I'm aware of have given it a try as well. I think the fact that ARC remains unbeaten and has endured for almost 5 years now is the strongest empirical evidence that we have that François' original definition of AGI is the correct one, and one that we should try to strive to go achieve. So I think that combination of evidence, both on the conceptual side and the empirical side, is what leads me to somewhat confidently say that I think AGI progress has stalled out. We've stalled out on generality. The systems that we are building today are no more general than the systems that we had several years ago because they're using the same underlying architecture, the same underlying ideas. LLMs are clearly not enough. They're insufficient. We need at least something new, something more on top, potentially in a completely different paradigm. And if you accept that's true, if you accept the fact that we need at least some sort of new idea, then I regretfully inform you that we are well off track on discovering those ideas compared to the sort of AI innovation ecosystem that we had even 4 or 5 years ago. All of the funding is going into LLMs. This is due to sort of the economic success of them. Last year, this is my counts of about 20 billion went into LLM startups last year. Maybe 100 million, a couple 100 million went into AGI startups working on new architectures, new learning algorithms, new ideas. Frontier research has also gone completely closed up. The GPT-4 paper had no technical details shared at all. The Gemini paper from Google a couple years ago had no technical details shared on its frontier, longer context window innovation. This is a really sort of unfortunate state we find ourselves in because the reason that I'm even standing right here talking to you all is because of a completely different innovation environment that we've enjoyed in AI from 2010 up until 2020. Just to recap maybe the brief history of the transformer, right? That's got cliff notes here. Started with Ilya at Google in 2014, a sequence-to-sequence paper. That got built on top of by, I think, Banadao at Jacobs University a couple years later. He coined the attention mechanism, right? That idea got openly shared and published. That got picked back up by Google with Swanee and Shazir. Google published the attention is all you need paper, realizing we can carve out a lot of the other craft around the architecture. Then that paper got picked up and shared and openly pulled into OpenAI, backed by Alec Radford and Ilya now again at OpenAI, who built GPT-2, 3, 4, so on, and here we find ourselves in today. So the reason we're here is because of open progress, open science, and open sharing. And that is the opposite environment, again, that we find ourselves in today. In fact, I go so far as to say, if you were someone in the room who maybe has a perspective that we should slow down towards AGI or pause or stop entirely, I think you should actually be pretty happy with the current state of affairs in the world today, because that's kind of what's happening. So all those things led me to pitch François this spring on creating ARC-Prize, $1 million nonprofit organization in order to re-accelerate open progress towards artificial general intelligence. The idea was to popularize his benchmark, ARC, and help provide a very public measure of actual progress, or really lack thereof, towards AGI. And ultimately, hopefully inspire a lot of would-be AI researchers or existing AI researchers to once again go back and explore new ideas, get back into that regime. We launched ARC-Prize, I think 1 month ago, exactly this week. And phenomenal response. Right now, when we first launched, the state of the art was 34% on the leaderboard. It's up to 39%. It actually jumped up really quickly a couple weeks ago. Then 39 since. We're number one capital conference in the world, tons of views on social. So I think we're starting to at least get the concept out there that hey, we're missing something towards AGI. We need something new. And I think even the progress of the last month shows that there's still a lot of room to go here. Since we launched, a bunch of feedback, critique, comments came in. I think the biggest one, probably this one: why no internet? Why limited compute? So it is true on Kaggle, you don't get to use internet on your solutions, and Kaggle gives you one P100 for 12 hours, limited compute. I'll address both. I think they're both important. Compute first. So why the limited compute? This is a really important part of the definition of efficient. Think back to Chollet's definition of AGI, a system that can efficiently acquire new skill. If efficiency was not part of the answer or definition, I should say, of AGI, it would mean that our AGI could simply be like a brute force. And yet we know that's not actually how we can do it. François goes into his 29 paper on a measure of intelligence, formalizes actually this with much math. If you're curious, you can go back and look at it. It's pretty interesting. I think more in introspection, if you just think of how you take the ARC puzzles yourself in your head, you don't sit there at this puzzle and try to think through what are thousands and thousands of patterns that might apply to the puzzles and trying to find the one that works. Instead, something in your intuition, your experience of having a lifetime of experience with these core knowledge priors allows you to shrink the possibility set from thousands, tens of thousands, millions of potential transformations down to just 3, 4, maybe 5. And then you deterministically are checking them in your head to look for the pattern that works. And then you apply the one that ultimately works. So this compute limit is ultimately to target that efficiency. We don't exactly know how much compute limits are, how much compute is needed to beat ARC for what it's worth. Last year, I think we've already over 2x, 2.5x the amount of compute you got from the competition that ran in the past years. And we're going to commit to continuing to raise the limits over time as time goes forward here. But I think this limited compute forces researchers at the end to reckon with this efficiency definition and doesn't allow you to get away with simply just brute force search. So the mission is for a bit more pedestrian, mundane reasons. We want to increase the confidence that when someone shows up and claims the 85% grand prize target, we have confidence someone's done that without contamination, without overfitting. It's a really important part of the puzzle, so the benchmark, that the AI systems don't get to see the puzzle ahead of time. That guarantees that they are novel, and it guarantees or increases the likelihood that the system is actually generalizing towards tasks that it's never seen before. I know how unsatisfying it is though to not know how your frontier model's doing on this benchmark. I personally wanted to know when we launched it. So just a couple weeks ago, we launched a second leaderboard. It's called the ARC-AGI Public Leaderboard. And this secondary leaderboard doesn't have prize money attached to it, but we've committed $150,000 towards a verification fund for it. And this is measuring the public task set. There's a set of 400 tasks in ARC that are public. They're in the GitHub repo that you can go use and train and evaluate your solutions on. This measures that you are on this leaderboard allowed to use internet. And we traded a compute limit for a cost limit. So you can spend up to $10,000 per solution. And right now, the top score on there is to Ryan Greenblatt, who worked really hard the first couple of weeks to get our first score established there. I think it's pretty interesting to see, by the way, how much agreement there is between sort of state-of-the-art on the public leaderboard and the private leaderboard. Not sure what to make of that yet, but I think it's pretty cool to see. We hope this public leaderboard can just allow a lot more rapid experimentation, by the way, too. Allow folks to get into the contest a little easier. If maybe someone in this room is thinking about getting started, Each of these scores have to go on the ARC-AGI website, find this, and go get the code. These all link out to a Kaggle notebook that you can use to like clone into your own notebook and get started tinkering and tweaking and get started from there. All right, so maybe I've convinced you want to work on ARC. How do you do it? This is kind of the history. I think these are some promising approaches. The 20 to 30% state of the art, pretty interesting because like there was basically no AI involved at all. Instead, what researchers did back in 2020 was they created a hard-coded DSL by introspecting the puzzles, and they did brute force search. That got to 30%. From 30 to 40%, we are starting to see solutions that, and the top scorer in the private leaderboard, what Jack Full is doing, is they call like test time fine-tuning, where he's taking like a code gen model and doing fine-tuning in the runtime to have some contact with reality about the puzzles systems never seen before and incorporate some information about that puzzle into the model in order to directly prompt it. And pretty interesting and surprising, it's getting up to 40%. I would suspect that we could probably use the existing ideas that are in the air and the existing set to get to maybe 50%, a little beyond 50% would be sort of my expectation for this year. But I think to get to the grand prize and beyond, we're going to need something new. And I think it probably looks something like a deep learning DSL generator. Instead of being able to look at the puzzles and build a hard-coded DSL out of it, I think we're going to need something that can automatically create that domain-specific language. And we're also going to need something that's doing a deep learning guided programs, sort of brute forcing thousands and tens of thousands of programs. We need to like leverage the like strength of deep learning, which is the perception ability to like shrink down that search space and somehow guide the programs to attempt to try. Last thing I'll address here is, does beating ARC matter? This is another common critique point of feedback that we heard. There's like this long history of AI toy benchmarks that just haven't mattered, right? Even all the games I mentioned, poker, chess, Go, researchers thought, only if we can beat those, we'll have AI, we'll have strong AI. And it turns out that didn't happen. So is that going to happen again? I'll be the first to acknowledge that beating ARC is a necessary but insufficient condition to get to the like scaled up real world AGI that we have. We're going to need to scale the solution to ARC. I like to think of ARC as like a minimal reproduction of what general intelligence is. We try to design it to be as small as possible to make it as achievable as possible at the current amount of scale and the current ideas that we have in the world today. And because of that, because AGI will necessarily be able to beat ARC, I think it's a good canary to tell us, has any system in the world uncovered even the smallest amount of weak AGI yet? From my Zapier experience, one of the biggest problems with the application layer of AI today is low user trust. And I don't mean like trust in data privacy or training data. Like certainly those are concerns, but that's not what I mean. The number one problem with the user layer is low user trust due to high hallucination rates, low consistency rates, low accuracy rates. And this means users who are building our AI bots are not choosing to deploy fully automated AI into use cases or deployment scenarios that have any amount of moderate to high risk. They're sort of forcing themselves to keep a human in the loop at minimum, or saying, hey, this is too risky in sort of in all cases, and we're just not going to do it. A solution to ARC, even the current benchmark, means if you can solve it 85%, you will have written a computer program that can simply be trained on core knowledge priors, arbitrary core knowledge priors, and that system can beat with exacting accuracy puzzles and tasks that it has never seen before. And that will directly lead to a ton of unlocked value at the application layer because it's going to directly allow us to solve a lot of these exacting accuracy and generalization problems that are resulting in low user trust today. Okay, so here's where we're at. AGI progress has stalled out. We need some new ideas. My bet is the breakthrough is more likely to come from an outsider. I don't think it's likely to come from someone in a big AI lab. I think they're very laser focused on the ideas and the research path they're at. I think it's more likely to come from an outsider. We need to like reinvigorate our AI innovation ecosystem again and try to tap into all the AI researcher brains around the world and try and inspire and convince and get more people working again on new ideas. So maybe you have them in this room. If so, I hope to see you on the leaderboard. Thank you.
Got a take question. So
Sure.
Background of all of her open source research, I think it's great. Laura's came out of lab, still context, who's not from a big lab.
Yep.
But a lot of the assumptions you made and stated with this is like, we need a different architecture. Ensembling, you kind of lose what's going on in your predictability. What would your thought be if, let's say, like GPT-8, GPT-12, just scaling a very bitter lesson approach solves ARC-AGI's down the line, right? So what's the bitter lesson approach to, is this benchmark going to stay? A lot of innovation is paused. I don't know if you see that, right?
Sure.
So like Claude 3 to 3.5 Sonnet, pretty big jump. Gemini to Gemini 1.5 Pro, big jump. GPT-4 to 4.0, retrade. Thoughts on bitter lessons, scale up?
Sure. Okay. Thoughts on bitter lessons, scale up. Will future versions of GPT-4 frontier models solve ARC? I think the first thing I'll say is like ARC is not perfect benchmark. We know that at least half of the puzzles are susceptible to just brute force search. This is back from data that we saw during the 2020 contest. Remember, back in 2020, no one was even using like transformers, deep learning. They were literally just doing hard-coded DSL and brute force search. And if you looked at the ensemble of all of the contestants who submitted solutions, about half the puzzles were brute force. So we know that it's not a perfect benchmark. That's actually like inspiring us to work on V2s for future generations, future years. I think our hope is that ARC can continually be sort of a frontier AGI benchmark and continually try to sort of define where does progress need to head in order to build AGI. Now, I think on the specific sort of take of like, are like language models sort of sufficient? You know, the way that sort of language models generally are working right now is they're doing like high dimensional memorization. They're able to like train off of examples they've seen in the training data. Ryan Greenblatt's public score is using 4.0, by the way, and he's getting 42%, right? I think one interesting thing about like that approach is not, I don't think it's actually due to this like just like contamination effect or overfitting effects. Like he had really good agreement with this like private test we benchmarked it on as well. Instead, what I think what's happening is because ARC has been running for 4 years, a lot of researchers have written DSLs and code to beat ARC puzzles on the public set and put that in GitHub. And 4.0 and other frontier models are training on those. So they're actually able to see these like reasoning traces and get that in. And I think solutions that are doing sort of program synthesis are like getting, they're getting closer to the state of art just by like looking at like what do other nearby solutions look like and recombining them in like kind of interesting ways deterministically. And that's what Ryan is doing. So at minimum though, I think even Ryan's approach is a new idea. He wrote an outer loop. He's not just doing direct inference and prompting the model, right? He's generating thousands and thousands of programs. He's doing an interesting kind of like search technique, an efficient search technique to not just like waste tokens and dollars. I think Ryan's approach shows that like something on top of LLMs at minimum is going to be required. I don't know that it's going to be necessarily a new architecture. I think transformers could be sufficient. There's like some research I found that, you know, the capability of transformers is quite high. It might be a learning algorithm that's the problem. But like there's certainly ways to brute force ARC. Like if you had a giant data center and you just brute forced every possible solution, or like trained a giant model to memorize every possible ARC answer or game board, you could brute force it today without AGI. There's ways to do it.
Yeah, I had a question. So you said like ARC isn't the perfect test, right? I mean, so even if we did solve it, like we did like AlphaGo, like what does that help us out with? Do you feel like also ARC should be evolving? And is there a comparative test or like sister brother test, something else outside of ARC that you find interesting? Or do you think ARC should evolve? Because like
sure,
that's like a big test.
Yeah, should ARC evolve? Are there other benchmarks that are similar? So when we launched ARC, I didn't actually know the answer to this. I was like, I think ARC is really special, but I don't know for sure because like there's a lot of ideas in the world. In the last week, no one has reached out telling me they have like a better AGI benchmark. My evidence is increasing that I think ARC is special. I think ARC is the only eval in the world that we have that was intentionally designed to try and create distance and separation between like AI and AGI. And I don't think there's more. Now, I would love to see more. I think there's some cool things ARC does. You know, probably the two key insights just to give it away are that like every task is novel and the structure of the eval has a private set that guarantees or increases the chance that there's no sort of novelty there and there's an efficiency on the test taking environment. I think those are like the main ideas that like are encoded in ARC that other benchmarks could like steal. Now, ARC is certainly not the only benchmark that's unsolved. Like SweBench, right, is another one that's got like really, really low performance measures. You know, generally, I think a first pass bar of like evaluating whether an eval is good or not is to look at how much novelty is in the set. If you have an eval that all the like puzzles, answers, and solutions or chatter on the internet has talked about like the solutions to them, I think that's probably going to be where you're not good. But you know, things like maybe the IMO competition, where every year they're generating new math puzzles and adding those in the data set. I think those are more interesting to look at as long as they're not just like, you know, appending it to the end, right? Because then your like novelty factor is reducing as time goes on. I think one thing I've heard François talk about, which I think is right, I think he's got a good vision for it, is that like the AGI benchmark is going to need to co-evolve alongside the technology. Right now, all 100 puzzles were created by humans because humans are the only one who have like the creativity and generality factor to create novel puzzles. Now, as our like weak AGI emerges, we'll probably want to use that in order to like make other puzzles and grow our data set to be bigger to like benchmark and test. And you kind of like stair step your way up alongside this. We've got some fun ideas in the future. V2 will probably just be a bigger data set that's still human created, but V3 might be something you've got like, you've got the ARC data set, and then you've got like anti-ARC, which is like a computer program trying to build programs that other programs can't beat. And you do like ELO style leaderboard or something. Some fun ideas for the future. But yeah, I think we'll want to like continually push the novelty factor up and up and up until we get there.